Smart meter is one of the buzzwords this year, important in every bingo. And Peter Haas is going to tell us how Germans implement it. So, warm welcome.
Yeah, hello, welcome to my talk, Smart Meter, a technology overview of the German rollout. The talk is divided into 4 parts, and I will start with an introduction. Why would somebody do smart metering? What are the organizations that are involved in the German rollout? I will present the guidelines and protection profiles that need to be implemented by the vendor manufacturers. I will give you an overview over the whole architecture of the components of the smart meter infrastructure, and at the end of the talk I will give a short overview of the cryptographical specifications. This talk will not be about if smart metering is a good or a bad idea, or if we can play blinking lights with it. It's just about the dry specifications. So short about me, I've studied at the University Bonn-Rhein-Sieg near Bonn. I'm one of the guys who's organizing the FrostCon, a free and open source software conference, you may know it. And I work for the Fraunhofer Institute Focus in Berlin. In the past I have done research in the area of wireless mobile backhaul networks and wireless sensor networks, and also a little bit on EPC networks. So let's start with the talk. Why would somebody want to do smart metering? If you have a look at the internet, you find different reasons. So some countries have huge problems with energy theft, with manipulated meters, so they want to have digital signed meters that are more secure or not. Other countries, especially countries with a low population density, want to automate the meter reading, so nobody needs to drive around the whole country and read all the meters. And at least the official reason why we do this in Germany is in Germany so-called Energiewende, which means the change from fossil energy resources to renewable energy sources. And therefore we need a smart grid, which is a term for an intelligent network where you have more control over ingress and outgress of energy into the network. Also, you have general reasons. You want to give the consumer of commodities a direct feedback of his consumption, so that you can just sit there and look at your iPad and see, oh, if I switch that light on, I need 20 watts more. You want a communication interface to buildings so that you can read status information from your building. You can see if something is broken in your heating system or something like this. And there is also a market for third-party services that will be possible over this communication interface. So yeah, the term smart grid also is always connected to smart metering. In a so-called smart grid, the role of the energy or commodity consumer switched to a newspeak word prosumer, which is a consumer who also can provide energy or resources. So an example, if you have a solar panel on your roof, you can provide energy to the network, and also you can consume energy from the network at night, or if your panel doesn't provide enough energy or what you want. We also will have distributed energy storages. So one thing that always is mentioned is e-mobility. So in the future, we hopefully have all electric cars that have huge batteries, so you can store energy in your car, or you will have energy storage in your house, so that if not enough energy is available from the grid, you can use that. We will also have a change from demand-driven production, which means at the moment the huge energy providers know from their statistics how much energy will be used, so they produce more energy or less. So, and in the future, if you will produce your energy with solar and wind and stuff like this, you can't choose, I now want to produce more energy or less, so we need to control the consumption of the energy. So an example, if we have much energy in the network, you can cool your fridge, you can cool your room with your air condition, and if we have less energy, we shouldn't do that. To enable that, the term CLS is there. CLS stands for Controllable Local Systems. That will be white goods like washing machine and stuff like this, or an example, the air condition. We will have availability-orientated contracts, which means energy will be cheap if it's available and it will be expensive if it's not available. And there will be contracts that should prevent you from producing energy peaks. So to catch peaks in the network, you need much power plants that can fill in if you suddenly need more energy. So an example of a big industry puts on big machines, they generate a peak in the network, and that's hard to cover with renewable energies. So yeah, we are in Germany, so we have a set of rules. The Energiewirtschaftsgesetz, the Energy Industrial Act, was put in place to deregulate the energy market, that you have a discrimination-free grid access. So in theory, everybody can be its own energy company and put energy to the network and get money for it. We have the renewable energy law, which should be an initiative to bring renewable energy more in the market, and it also defines the rollout of the smart meter in terms of when they need to be installed and which rules apply for the installation. And we have the Netzausbaubeschleunigungsgesetz. It's increasing grid development law in English, and it basically should speed up the extension of the German power grid. So on the one hand, that we can connect it to offshore wind parks and something like this, and on the other hand, that we can bring huge amounts of energy from one part of the country to another part. An example, if you have much sun in Bavaria, you need to transfer the energy to the other part of Germany to the consumers there. So that's with the actually grid not possible. Also, there are many agencies involved. We have the BMWI. It's the Federal Ministry of Economics and Technology. They are in charge of everything concerning small and middle industries, enterprises and industry. We have the BMU, it's the Federal Ministry of Environment, Nature Conservation and Nuclear Safety. They are especially in charge of reactor safety and nature protection. The BME, Federal Ministry of Interior, so that's public safety, public services and all this. And yeah, the agency you will have heard much about on conferences like this, the BSI. They are in charge of e-government, IT business, level security, certification, electronic ID, and smart metering. Also, there are some associations involved. They come from every sector: energy, telecommunication, IT, housing, industry, researchers, universities, and it's a really good mix-up. So you will see that the specifications are, from the security point of view, not that bad. So when start all this, in 2006, there was an EU directive for energy efficiency that brings a little bit the whole process ongoing. In 2008, the Energiewirtschaftsgesetz was renewed to also allow different parties to do the measurement. That's important for this whole smart metering thing, because your operator will not always be your measurement provider. That's possible because of this law. In 2010, the BMWI charges the BSI with the development of the protection profile and the technical guidelines. That's the two documents this talk will be about. Since January 2010, all new buildings in Germany and all buildings that get complete renewed need to be equipped with digital meters that are not necessary smart meters in the sense of the protection profile and the technical guideline, but at least they have to be digital and have to be an interface which is machine type readable. In 2011, we have seen the first draft of all these documents, and since 1 week we have the final draft, which will be evaluated until end of January, and then we will see the final documents, and after that we will see meters and gateways that implement this guidelines. That's the reason why we can't see nice hacks of this up to now, because there are still no devices. And yeah, up to December 2013, can still be old infrastructure can be deployed in the buildings, and after that, every device that will be deployed needs to fulfill the requirements from the specifications. These are basically two document sets. One is the protection profile and one is the technical guideline. There are also some related technical guidelines which, in example, define the cryptography aspects and which elliptic curves should be used for the encryption and all this. So let's start with the protection profile. It's a common criteria how all this should be implemented. It's based on the ISO 1548. It defines the security function and the requirements. For an example, how the physical implementation of the meter should look like, which components should be in the same housing, which should be in different housings, how the security module should work and interact with the meter, how and which interfaces the device should have, how measurement data should be handled, how this data should be protected inside the device and on all communication interfaces, and which management function should be available to which parties. Also, it defines the assets and a complete threat model, so if you are in the security business, you can use this threat model to look if your meter fulfills it or not. The technical guideline extends the protection profile mainly with functional aspects, and also it gives a huge number of rules for interoperability, that all equipment from different vendors can play together nicely. And it also gives additional security rules. This is an overview of the technical guideline. It's divided into 5 parts. The first part defines how a smart meter gateway should work. The second part is about the security module, which is in charge of the whole cryptographic infrastructure. We have cryptographic guideline and the PKI guideline, which defines how these two aspects should be implemented. And the last one is about the communication adapter, also about the interfaces. And for most of it, there are also test specifications that will be used for the evaluation process. So the most important aspect to understand all this are the roles in this new system. So formerly you have basically the consumer and the producer and sometimes somebody between that sells you your energy. Now you have a huge set of parties you have to deal with if you want to have energy at home. The consumer, that is yourself. It's the person who consumes energy, it's not the owner of the building. You have the grid operator, that's the party that operates the cable in the street. You have the supplier, which can or cannot be the producer of the energy. Supplier is usually the party you have your energy contract with. The producer is usually the entity that operates the power plants. You have a meter operator who comes to your building and installs the meter and repairs it if it's broken. You have a gateway operator who comes and installs the gateway and repairs it if it's broken. You have a meter administrator who administrates your meter, and you have a gateway administrator who administrates your gateway. You have a gateway developer who is in charge of developing the gateway and needs to provide actual firmware updates on every update of the technical specification. And you have a profile provider that defines profiles. Profiles in this context are definitions which data needs to be developed, delivered to which entity, if it should be pseudonymized or not, in which interval it should be delivered, and stuff like this. And you have external entities who, an example, want to process your data, or could be somebody who will help you to optimize your energy consumption or provide additional services. So, oh, it's not that good. This is an overview of the whole thing in your house. You have 3 networks. You have the WAN, the wide area network, which is the connection to the gateway administrator, who will sit somewhere behind the internet. You have the HAN, the home area network, which can be your local LAN or can be a different network. That depends on how you want to do it. The HAN connects on the one hand, the HAN provides the interface to the user, where the user can read the metering data, where the user can define some settings, and it's also the interface for a service technician who will come to your house and fix something. Also things like the energy storage and the e-energy car will be connected over the HAN. The LMN network is a local meteorological network, and in it all the meters will live. It's the only not IP network, everything else will be IP. So on the one side you will basically see everything that can encapsulate IP. So there is no real guideline what it will be. More interesting is a logical meteorological network. There you have the MBUS interface. It's already used since years for metering, but the new for the technical guideline, they have new cryptographic specification for it, as the old one was broken. It's basically a broadcast communication network which can be 2 wires or wireless. Yeah, and in the HAN you will also use IP communication, so you will have Wi-Fi or power line or what is fitting to your building. The smart meter itself is a small PC. At the end you have some interfaces. You have the meter needs to provide a wired and a wireless interface. It needs to provide a display for the end user to see the readings. It needs to provide a front interface for the user, and it can provide a legacy output that's a small infrared output where you can put basically a serial interface. Yeah, and of course it has a power connector where it does the metering. The meter has relatively obvious tasks. It records the consumption, it submits the records to the gateway, and it needs to sign and encrypt all data for the LMN, so even in the building everything needs to be encrypted. And it needs to be calibrated and sealed, which will be interested because the firmware needs to be calibrated and sealed too. The smart meter gateway has the same interfaces to the LMN and additionally the WAN interface. And it has a crypto module which is not part of the meter itself, so it will be installed in the device and can be removed or exchanged. The tasks of the meter are handling the metering data, protection of authenticity, integrity, and confidential of your metering data. It is a firewall to all the 3 networks we have seen. It needs to provide a wake-up service for the administrator where he can trigger a connection with. It's in charge of privacy preservation. I come later to that. And it needs to handle the profiles I mentioned earlier. And another important task, if you live in a building with many flats, you will only have one gateway. So the gateway needs to make sure that the metering data of the different people that live in that house are separated and that only you can access your data. Also, it needs to be firmware updatable, and it provides some security services to the devices in the HAN that are supported by the security module. Privacy tasks for the gateway are communication concealing. That means it should be put random padding in the communication and stuff like this so that you can't guess what communication happens and how often it happens. And it does pseudonymization. That means it removes IDs of the meter from the data in the first step, and in the second step the gateway administrator removes your gateway ID so the data can be used pseudonym for statistical evaluation and stuff like this. it does data level encryption. So we have all encryption, all communication happens in TLS channels, but the data in the channel is also encrypted. So in example, you want to provide your measurement data to an external party and you don't want the gateway administrator to look in it. So you have two-layer encryption for that. And yeah, again, user authentication, which basically will happen with German EID card or equivalent authentication methods. The meter has a number of logs. It has a system log that logs system events, power losses, and everything that is available for the administrator. It has a consumer log where every access on your data will be logged. So if somebody accesses your data, your gateway administrator or somebody else, you have it in your log file. This log file is only available for the end user, so you can always check who reads your data. And it has a calibration log where every calibration relevant events will be stored. If you want to do metering, you need an exact time. And obviously, if you have time diversing tariffs, it would be really nice if you could adjust the time. So therefore, time updates are only allowed over a secure TLS channel, and no DCF77 or GPS or stuff like this is allowed. Also, there are some methods in the specification to prevent fraud on this. In example, you can't do huge time jumps without notification of the administrator. The device itself has relatively basic security features. You have memory encryption, you have a pace authentication between the security module and the device itself, and you have a firewall. Something like intrusion detection or something like this is not mentioned in the specification as far as I know. Yeah, as mentioned earlier, the meter is the gateway is in charge of the communication. Its basic functions is to build open the TLS channel to the gateway administrator. It will send the metering data. It will send to external parties or to the gateway administrator. It will open the CLS interface to the LAN side and provide the TLS proxy for it, so it can devices from the LAN and HAN can connect to external parties. It needs to report every errors to the administrator and provides an administrator interface via a wake-up service. The whole communication, so the communication to the gateway administrator, to external parties and everything like this, will happen through a RESTful interface. There are so-called COSIM interface classes that are defined, that defines the whole interface. Access happens via HTTP. We have XML transfer syntax, and yeah, addresses will look like at the bottom, so yeah, it's basically REST. Yeah, the wake-up service is a nice feature. So the meter is not the gateway is not allowed to provide any services to the WAN side, but you need a way to communicate with the meter to bring him to contact his administrator. So you can send him a packet which needs to be signed and have a recent timestamp. And if that all is valid, the meter can open the connection to a pre-configured IP address. So that means you can't, or you shouldn't be able to own them via the wake-up service, and there should, in theory, no other open services. So that's a good idea, I think. Yeah, the firewall of the meter should separate the three networks. Connections are only allowed from HAN to HAN and from HAN to WAN, not in the other direction. The LMN devices are not allowed to communicate with any other entity than the gateway. And connection from the WAN side to the HAN and the LMN are forbidden too. So that's the firewall basically. The security module is a separate device which will be in the housing of the gateway itself. It's a cryptographic service provider. It stores all keys and certificates that are needed for the whole infrastructure. It can be a smart card or soldered in module. In the recent version of the specification, they also speak of wireless communication, which will be NFC, but I'm not completely sure if it will be derived from the e-card system, but I'm not sure if it's the same. But they use also the same authentication mechanism, the PACE mechanism. Yeah, cryptographic support, it does the key generation inside the modules. Keys will never leave the module, hopefully. Cryptographic operation will all be done in the security module. It also is required to do key destruction, so every old material that is not more used needs to be secured erased. What does ZB is also specified, so it's not only, yeah. It is, does the signature operation, it does the user data encryption, and it also does the random number generation, so we hopefully will have good random number generators. Yeah, at last we have the TR131163, which is, defines the cryptographical details. It's part of the e-card project of the German government. Yeah, it defines and it defines also how the PKI will work. So we will basically have a national root CR, some sub CRs that provide keys for all the energy provider and all the parties we have heard before, and also it will generate the end user certificates. All signatures will be based on ECDSA, also known as elliptic curve DSA, and all transport layer, as mentioned earlier, will be TLS. What TLS is luckily defined too. It needs to be version 1.2 or bigger, no fallback allowed, and yeah, the basic known features that you want in such an infrastructure. Yeah, the random number generator are also specified that need to be used. And the last interesting part that is defined is the initialization. So where comes the initial secret to the device, where comes the initial certificates to the device, which is a really huge problem because most of the meters will come from China or from somewhere else where you really can't control the environment where they will be built. So the idea is that the meter comes without any cryptographic material, and it will be generated on the first boot up, and then deployed into the private keys will be deployed into the smart meter gateway from its administrator. The gateway itself will be shipped with an initial key. This key needs to be deployed into the security module. That can happen during the manufacturing process. That can happen by your vendor supplier or your operator. Or it can happen during the installation process, which is not, I think, not the best place to do it. And the last component is the security module that will come with a vendor certificate and key material and will be exchanged from the gateway administrator on the first connection with the smart meter gateway or before installing in the facility of the gateway administrator, which should be a secured area. Yeah, also the hashing function are defined. That is not that interesting, I think. Oh, you're good in the time. So, and at last it defines the communication in the LMN network. There is also TLS required, if possible, because there are also meters that can't communicate in a bidirectional way. So if you can't communicate bidirectional, you can't do TLS. Therefore, a fallback is defined where you basically have a symmetric cipher where the private keys need to be deployed by your administrator on the first time you connect the meter. As mentioned earlier, all the data that goes through the network need to be encrypted and signed. And rekeying for all the meters is required every 2 years. I have here some links. Sadly, I couldn't find everything, every document in English, but the English Wikipedia has much material about the German smart meter rollout, so I hope you will find the information you need. If not, you can contact me, and if you have any questions, I think we have some time left.
Yeah, thank you, Peter. If there are questions, we have 3 microphones open on the 3 aisles, so please line up. No questions from the internet? Okay.
Yeah, it's not really. It's a technical question, but that does not go into this whole cryptographic direction. It's more about the accuracy of smart meters, actually. So, as these things are all consuming money, one is interested in the accuracy of smart meters and how about the apparent power of devices and also the device itself. How does one deal with that? I don't know if you specialize in that.
The question was about the accuracy. There is also an ISO specification that said it's. I don't know the exact number, but the interval is not specified. You can, how often you get a reading. That's basically a setting which is set by the profile, and the accuracy of the meter itself. It has a class name. It's class E, but I can't. I have to look it up. What's the exact details? I can look that up later if you want.
What's yours in response, or?
No, another question.
Okay, then you.
Hi. There's over here.
Ah.
Hi. There's a lot of networking stuff defined in these specifications. Are they V4 or V6 or both? Either?
That's a good question. That everything, as far as I know, everything needs to be IPv6 ready. But I didn't find it in the documentation, so it's not specified in detail, at least not in the documents I read up to now. But as I mentioned, the documentation was updated in December, exactly at December 21, so I didn't manage to read all the new documents. Hopefully it is in one of the new ones. It's in a few thousand pages.
Okay.
Okay, the middle aisle.
Is there any regulation about the temporal resolution of metering? Because I think you can find out a lot about inhabitants of an apartment by watching the power consumption, what they are doing and how many people are in there and so on. So is there any regulation to limit the temporal resolution?
The specification says that the information that your external party gets is only the amount of energy you have consumed, not the time when. So basically the resolution depends on your contract. The providers are required to offer you a contract with a reading 1 time per year. So that basically means they get 1 time per year the information you have consumed, 6,000 kilowatts or something like this. But if you want a time flexible tariff, the reading needs to be more often. So it's basically on the end user. If you choose you want a standard tariff which reading 1 time per year, they only get 1 time per year value. So yeah, that's the option.
Okay, on the right.
Yes, thank you for the really informative talk. For a couple of questions about the scale of this project. So how many smart meters are to be expected in households, and how big is the whole market here? Is there any discussion about the acceptance? Because all these other big electronic governments projects, and this is in a way part of e-government in Germany, have failed so far. So there's little acceptance in the EPA or Gesundheitskarte or any of these things, that also brings me to the next question: who is really driving this? Is this the energy sector? Is it the government? Is it the IT sector? So who are the stakeholders? And
let me start with the first question. I already forgot your second one.
Yes.
Can you repeat the first one?
The question was. how many smart meters?
Right. As I said, since 2010, every building which will be renewed or new build gets one. That's still true. So every new building gets one. After that just changed a few weeks ago. I think after December next year, they changed the date because the specification wasn't ready. Every industrial building gets a smart meter, and every household with a consumption over 6,000 kilowatt per year. And so I think over the future we will get all one. Expect you live in a really old building and use less energy. But the plan is that everybody gets one, so the smart grid idea could work.
Yeah, I'm just wondering how many households are there in Germany. I mean,
sorry.
40 million. Okay.
I heard 40 million.
Okay, so okay. And further on, could you say a little bit more about the planned integration with the elektronische Personalausweis? Is that just a tool for doing the billing, or is there anything more complex involved in there?
The idea is that you access your readings with it, so you go to your meter and authenticate against it, to your gateway. So the second idea is that you can change your energy contract with it. So you can authenticate against a web portal or something like this and say, okay, now I want this contract. So that's the basic usage of the EID.
And how about data locality? Where is billing data, energy consumption data, and so forth stored? So multiple storage points, or is it in the machine, or with the vendor, or?
The meter the data itself are stored in the gateway. The period depends on the interval you have in your contract. So if you get your readings every 5 minutes, the time the gateway will store will be shorter because the lock will you have not the space will get full. Yes. The external parties are asked to delete the data as soon as they are not more used for billing purposes. And there are also these data that get pseudonymized. I'm not sure what the other requirements, but I think that can be stored by the external party as long as they want.
And could you say something about the stakeholders too? I mean, who really is driving this in Germany?
Yeah, so there is no real official news statement about it, so it's just my feeling. I think the big interest was building operators and building owners, because it's easy for them to, or better for them to have a direct view on the state of the building. One example that they come to us was they want to get the actual status of the heating engine in the buildings, because then they can see if it's broken and save much money. Another big stakeholders there are the equipment vendors, because they want to sell new meters and new gateways. I think network operators, telecommunication network operators are also big stakeholders, because they want to sell the M2M platform for all this. And the government itself is driving it because of its initiative to switch over to renewable energies. Mm-hmm. I think the energy provider itself are not that interested in it, but that's just a feeling. I have no proofs for that.
Okay, and my final question is there any discussion on having some fine-grained emission certificate trading based on smart meters? I mean, you could break down emission certificate trading from the industrial level to a household level with this, basically create new secondary markets. Is there any, to your knowledge, talk about that?
It's an interesting idea, but I haven't read anything about it, so possibly that there is one, but the idea is to lower the emissions with this initiative, so hopefully we don't need to trade anything if that all has happened.
Okay, thank you.
Thank you.
Okay, so for clarification here, if employed in a smart grid, does this smart meter somehow regulate the power consumption of all the devices in the house? That's somehow that came over like that.
it can, there is this CLS interface which I mentioned. This is the interface for your household devices in your household. So you can, the idea is that you can allow an external party to say your devices, now it's a good time to operate. So an example, one example was the air condition. So the idea is that could be work on two ways. One way is you have your contract profile in your gateway, and your gateway just informs your device, now it's energy cheap or now it's energy really green. And the other option is that you have an external party that connects over the CLS interface to your internal devices and do this activation for you.
Okay, thanks.
The middle aisle.
Does this architecture allow to turn off the power of a household?
Yes and no. The specification says that the meter and the gateway is not allowed to have any influence on your energy delivery, but it also says that you could have a device behind that in the HAN that switches this off. So you could think of something like prepaid energy, but it's not the infrastructure itself. That would be a different device that is controlled over the interface. So you can say yes, but you need, it only happens if you choose a contract that works that way. So that the devices that get everybody will not be able to switch off the energy delivery.
I have two short questions. One is, there are some indications in California that the radiation that comes from these devices might be a little bit higher than what would be healthy for humans. What are the studies on that, and what is known about that in Germany? And my second question is, how much of these installments is voluntarily, and are there consequences or fines if you don't comply to install them?
Radiation? Did you say radiation? Yeah. I'm not aware of any studies about that, but I opened some of that devices, and it's just basic Linux computers with some metering equipment. I couldn't imagine that it has more radiation, but if you could point me to that studies, I would like to have a look at it. And the second question was if it's required. Yes, it's required for the industry, it's required for households over 6,000 kilowatt per year, but this both will happen in the future, so there is no precedent, actually, up to now, nobody could say he doesn't want it because he doesn't need it to have it, so I don't know what will happen if you say, no, I don't want a smart meter. Okay, over the right aisle.
As an end user, I will not be able to look into the software, the firmware for the smart meters and so on. So how credible can the auditing options for the user really be?
Yeah, that's a good question. The only thing you can audit is that, what is in the protection profile. You can look if there are open ports and something like this. You will not have, at least if the vendor doesn't publish the firmware, will not have the option to look at it like on every other consumer device sadly at the moment. There are some projects that try to build an open source smart meter gateway and an open source smart meter. The interesting question will be if that get a certification or not. So there is no point in the specification that says that the firmware can't be open source. So if the implementation works like the specification and you find somebody who pays the certification process, it's possible that an open source smart meter could happen.
Left aisle. Hi, Peter. One simple question. Have you had the chance to evaluate actual devices in regard to software security, or where do you think security flaws may occur?
I have a look at some devices, and one of the devices has some open ports that it shouldn't have and an open FTP server, but all devices that all devices that are at the market at the moment don't implement the protection profile and the technical guideline because they are both not finished yet. So we will have to wait at least until end of January to get devices that implement this security guideline, and then we will start with the fun again and we will see what happens. So as mentioned earlier, the protection profile says no services are allowed on the WAN side, no administration interfaces are allowed on the HAN side, except they are especially enabled from the administrator and stuff like this. So in theory, that could be a good infrastructure. We will see what the implementer will do with it.
Thank you. I'm definitely looking forward to your next talk.
Thank you.
Yeah, when you're talking about the tariff option where only once in a year it would be measured, wouldn't this just cancel out one of the most biggest advantages of these smart meters,
yes.
Which is the quicker reaction on the consumption?
Yes, it's an option that is the option is there to protect the privacy of the people. So if you are afraid of a daily reading or a weekly reading or reading per minute, then you have this option, but it's not the idea of the whole smart metering. But it has still the advantage that you as a user have a look on your current consumption. So you can still have a look at the readings and can see, oh, I think I need a new fridge. The old one takes too much money or energy or stuff like this.
Okay, outer aisle.
Yeah. From what I understand is that these regulations affect the smart meter and gateway on the consumer side. Are you aware of any regulations which are also regulate the receiving side, so the providers or the energy suppliers?
On the provider side, the usual protection profile for entities who are involved with user data applies. So everything that applies to your email provider or stuff like this applies also to the entities. There is a huge specification how you have to secure the data storage and all this. The question is how to evaluate that. So how you make sure that external parties don't lose your data or something like this. That's a different topic. But in theory, there are already regulations that apply to everybody who is in contact with personal data.
But there are no special regulations like how these suppliers exchange their data between themselves and so on, or what they are allowed and what they are not allowed?
I'm not 100% sure if there is not an additional document that says something about it, but I need to look that up.
Okay, thanks.
Please speak into the mic. We won't hear it otherwise.
I would like to answer that quickly. The gateway administrator has to be ISO 27001 Grundschutz zertifiziert. That's all.
Yeah, there is a nice German word for everything.
But is there a law or a regulation for that he has to do it, or I mean, is it somewhere written?
Yes, it's in the TRs, one of the TRs. So he is not allowed to be a gateway administrator if he is not certified for this. But that TR is quite short, so it's 3 pages.
Thank you.
Okay, then next questions here. Yeah. Front row again. Sorry. Before the rollout, how is I mean, there are some households that already get some. We saw that in the press. The first meters were installed. How is the whole project tested for scaling at such, as there's going to be such a large number employed?
Sorry?
The scaling test. How is the whole project tested for scaling? I mean, you can, yeah.
Yeah, your contractor or it depends a little bit on your personal situation, depending on who will install the meter in your household. So the energy provider or your energy contractor needs to do the installation, and he also needs to pay for it. so they can do the way they choose the way they want to do it. So basically, they need to send you a technical guy who installs it. But yeah, they have a little bit of time. So only for new households and renewables at the moment, so they don't have to roll out it in the whole Germany in a month or something like this. So it will take 10, 20 years because every household has one. So
Middle aisle.
Yeah, so you said that the end user devices will be certified using common criteria. Usually there's evaluation assurance level, so AEL level, that goes from 1 to 5, where 1 is this very simple, and 5 is complete formal verification. I guess if they managed to actually have an open FTP port that was not completely formally verified there. But so what is the actual level there? Because that will mean quite a bit of burden for a semi-formal verification level 4, for example, if this needs to be done in open source and has to be verified. There's a lot of money and time involved. So what is the level required?
The specification is based on the common criteria. It's not one of the levels, so they just took the good parts from it. Every meter needs to fulfill the same requirements.
So it has bad parts.
Yeah. It roughly, yeah, it's 4+. Yeah,
4+.
4+, yeah, that's typical. Okay. So it's semi-formal plus some other show. Yeah, okay. That was my question.
Okay. Left aisle.
Okay, so you mentioned that there might be third-party companies to use the data. Have you got any examples what they might be interested in, or if there are any companies who are already looking for this data?
An example that I've heard was that so an external party could analyze your data for you and give you suggestions how to optimize your energy consumption. That was another external party you could be interested is not in your data itself, but in the interface to your house. So one option was emergency systems for all people that at the moment are connected via the telephone line that could be now connected to the emergency central via the smart meter gateway. And also you could think of something like insurance companies that want to see if there's really a lightning that destroys your TV set or something like this. So there are many options. So basically we will have an IP connection to every building with some security around it, and every service you could think of over via the internet could happen over the smart meter gateway basically. So there are many options.
Okay, middle aisle. You.
Would it be possible to record at which price energy was consumed and then sum that up and read it at the end of the year? So eliminating the privacy issues and still have the higher resolution and final if the smart meter knows the price of the energy at the moment and then it sums it up over the time. And
I understand the question. I think technically it's possible. I'm not sure if the guideline allows that or if your contract provider will be willing to do that. But all data is signed. All data should be protected against manipulation. So I think there's. I have no reason why not.
Thank you.
Okay, front row again. So I think my scaling question was somehow ill-phrased also, I don't know. It was basically about the dimensions of the project, since this is going to be employed all over Germany. How do you make sure that like 50 million smart meters communicate correctly with each other?
How to make sure that they communicate correctly? Yeah. You can't make sure that in advance. You have the specification that hopefully covers all aspects. They're working on it for now 3 years, so I hope they have everything kept in mind. But there will be, you have the, as mentioned earlier, you have a testing specification for every aspect where completely stand which interaction should work, which interaction shouldn't work. and under which condition it should work. So hopefully you can just go through all the test specifications, and at the end you have a product that work together. But at least it's not really your problem, it's a problem of your operator. So there will be huge interest in a working communication between different vendors, because you can change your energy provider, and your energy provider will or will not bring you a new smart meter, but the gateway will stay the same. So the industry has a really huge interest in in infrastructure that works together. So I hope that will enable products that work together.
Okay, middle aisle.
Okay. The specification is only on the smart meter itself and not on the backend systems. So, for example, could I simulate 1,000 smart meters and report that everyone is using the maximum of the current? So they are providing too much power to the grid.
If you have valid certificates and valid keys that are accepted by the gateway administrator, then yes, but every meter and every gateway that is in the network of one operator has its own private certificates that are well known by the operator. So if he don't screw up his infrastructure completely, he should see that your 500 simulated meters are not the real ones.
But is there a specification how the interface on the provider side?
Yeah, that's its RESTful interface I mentioned earlier.
Okay.
Middle aisle. Yes, you.
One question only. How much does one smart meter consume in power?
That's a good question.
Yes.
It's not specified.
And who does pay for it?
I wanted to do some measurements before, but the measurement device didn't arrive in time. I think it's about 1 to 3 watt, but I couldn't measure it myself up to now.
If it's 1 watt and we have 40 million people using it,
yes,
so we have
complete
40 megawatts only for the infrastructure.
The complete infrastructure, not the meter on its own, the gateway and all the things you have in your building that are basically Linux routers, so they consume nearly the same. It's a small arm in all devices I have seen now. Yeah, the infrastructure will consume a huge amount of energy.
Okay, thank you.
Okay.
So what happens when the smart meter somehow crashes or something doesn't work, and yeah, what happens to the accounting? Is it the provider's problem or is it your problem if yeah, something goes wrong?
Good question. At first, it's the provider's problem, as long as he can't. Yeah, it's the same like your meter breaks down now. So if your operator comes to your house and a big hole is in the meter, then it's your problem. But if it's a software fault or something like this, then it's a problem of the provider. But that's a question we will see in the future, how that will be handled in reality.
Okay, outer aisle.
About the energy consumption of the infrastructure, it may consume a lot of megawatts, but it's probably much less energy than a bunch of guys driving around Germany with a clipboard reading all the meters manually.
Into the microphone, otherwise we won't get a joke.
He says that the guys don't always drive around to get the readings. That's true, but there are still guys driving around because they make regular checks if you provide the real data, and especially if you change your flat or something like this, then somebody needs to look up if the readings from the last guy who lives in the flat are correct and something like this. So, but I think that's not a point to evaluation. Then we can also say, let's switch down all the DSL, these lamps, because they take much energy. That's not really the option at this point, I think.
So, okay, time is up. Thank you for your attention, and thank you, Peter.
Thank you.